1.2, sampling and experimental design. So when we looked at this section, there's a couple of different sampling techniques that are explored. And probably the most popular sampling technique is called the simple random sample. It's simple, it's random, and you're collecting a sample. Okay, so this is commonly like a survey or something like that. So you go out and you randomly select 4 people from a group of 10, right? So 1, 2, 3, 4, that's who you elect to sample. You collect data from them, and then you analyze that data, okay? So that's called a simple random sample. Put the names in a hat and draw out 4 names, and that's who gets to take the survey, okay? Another way is called the systematic sample. And you've seen systematic samples probably in a gym class sometime at school where the instructor said, okay, everybody number off. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, all the ones you go over here, all the 2s you go over there. That's what a systematic sample is like. For example, you elect to sample every 3rd name on a list. So 1, 2, 3, 1, 2, 3, 1, 2, 3. You get a sample, you get a sample, you get a sample, or a survey to take, okay? And so that's a systematic sample where you organize the group in some fashion, and then you determine a systematic way of selecting who gets chosen to participate, okay? The next 2 are very closely related. One's called a stratified sample, and the other one's called a cluster sample. So for a stratified sample, what you do is, let's say you got 50 people and you want to determine of those 50 people, who do we choose to complete a survey? Okay. So you take those 50 people and you're going to break them into 5 different groups called strata. And then from each group, you randomly select 4 people. So from strata number 1, this person gets a survey, this person, this person, this. So person number 2, 4, 5, and 10. So again, this is person number 2, number 4, number 5, and number 10. You get to participate in our survey, okay? Then you go to the next group, the next strata, and you select person number 4, 5, 7, and 10. So you randomly select 4 people from each strata, okay? Every strata gets selected, but only 4 people from each strata participate in the survey, okay? Another type of grouping that is very similar to this is called a cluster sample. And what you do in a cluster sample is, once again, you divide the group of 50 people into 5 different clusters this time, 5 different groups, okay? But instead of selecting people from each group, you randomly select an entire group. So you randomly select cluster number 2, and everyone in cluster number 2 gets to take the survey. And everyone in randomly selected cluster number 5 gets to take the survey. So everyone gets the survey. So you can see how they're similar. In both of them, you're breaking the group into subgroups, strata and clusters. But in the strata, every strata has someone in it that gets randomly selected to participate in the survey. Where in the cluster, the entire cluster gets randomly selected to participate in a survey. Okay, so make sure that you know the difference between those 2. If you want to survey the entire population, everybody, that is called a census. And the United States government does a census. They come around and they'll knock on your door and they say, how many people live here? And you say 52, and they write it down and they go to the next house. And they knock on the door, they say, how many people live here? And you say -5, and they write it down and go to the next house. So census information is very useful for a government, because we need to know where should we build roads? What highway infrastructure needs to be improved? Should we widen this freeway from a 2-lane to a 3-lane, like going in one direction, you know? It's those types of things that a census can help a government understand and use data to make decisions, okay? So a census is when you go out and you survey everybody. Very difficult to do, very difficult to do. It's not easy surveying 330 million people, okay? And so it's tough to do a census. If you do want to go and view some of the information from the United States Census, you can go to these websites, and they actually got some pretty cool data that look at census information. Who composes the United States? And where do they live? And what do they do? How old are they? Pretty interesting information. Okay, so those are sort of the types of samples we can do. One final sample type that you probably shouldn't do is called a convenience sample. Yeah, it's convenient. Isn't that nice? But usually that convenience has implied bias built into it because of the nature of being convenient. For example, if you wanted to do a survey and ask people what their favorite type of music was, and you went and surveyed a convenient sample, all your friends. So you went and you asked all your friends, what's your favorite type of music? Chances are they're all going to say sort of the same thing because they're your friends. The reason they're your friends is because you all do similar things together, right? You're homogenous, if you would, you kind of, you wear the same style of clothes and you listen to the same type of music and you like the same type of movies. Now, not identical, obviously, but in general, you kind of do the same type of things. That's a convenience sample. There's a bias built into it. So if you were doing a survey to figure out what the average person in America likes to listen to as far as music is concerned, doing a convenience sample doesn't represent a wide variation of Americans. It represents your close circle of friends, and there's probably some inherent bias built into that. So this is why you don't want to do a convenience sample. You want to try to get as broad a spectrum of the population as you can when you're doing sampling. Okay, so here's a quick summary of these samples, kind of written up for you in a symbolic nature. Don't do the convenience sample. And then we're going to finally talk about experimental design. And these are just all examples of that. So when we talk about experimental design, again, I'm sorry that this is all vocabulary and it's boring. And I want to just jump right into the mathematics, but we've got to establish this first. So there are a couple different types of experimental designs you can do. The first one is called an observational study. Okay, so you get your lawn chair, you set up camp at the corner of a four-way stop, and you record the color of every car that comes into this four-way stop. Okay, that's an observational study. You're just kind of hanging back, observing, recording some data. Okay, nothing too aggressive. You're just kind of observing, right? An experimental study, though, is where you purposefully take action in order to determine whether or not, for example, a treatment works. So maybe there is a new pill that is on the market that says, if you take this pill, you will lose 50 pounds. Okay, great. Well, we have to have a way of experimenting, of testing this, okay? And most of the data that we collect is going to be experimental data. And so what you want to do is set up something called a randomized treatment experiment. So what you do is you take participants and you break them into two groups. Group number one is the treatment group. That's the group that gets the medication. You get the special diet medicine. Okay, here's the pill. It's got the diet medicine in it. You take it and we'll watch and see if you lose weight. Okay. The other group is called the control group, and they receive a fake treatment. They receive a pill, but it doesn't have the magic diet medicine in it. It has sugar. It's a sugar pill, and it doesn't impact their system at all, because you got to know who gets the real treatment and who is in the control group. The reason you do this is because something called the placebo effect. So the placebo effect is the idea that you respond to something more psychologically rather than physical. Okay. If I gave you a sports drink and said, hey, drink this sports drink and you're going to run faster. And so you drink the sports drink and then you go run. And then I survey you afterwards. I say, hey, did you feel like you're running faster? You're like, oh, yeah. Yeah, I totally felt like I was running faster, man. I could feel the sports streak working through me and my energy. I was just going. And it's like, yeah, well, that was water with food coloring in it. I didn't actually there's nothing magical in the sport. Oh, what? Right. That's the placebo effect. The placebo effect is you psychologically thinking that something is happening when in fact it's not. It's kind of superstitious. I don't want to say superstitious because they are separate, but it's sort of like believing in something just to believe in it, right? Do you think you really felt like you ran faster? Oh yeah, I felt like I was running faster because I drank that sports drink, right? And so what we need to do is be able to tease those apart. Make sure that we know who's getting the real treatment and who's receiving the placebo, and see what the results are. Okay. That's a randomized treatment experiment. And so we can do this a couple different ways. Here's one example where you take the men, and half of the men receive the control, the sugar pill, the other half receive the treatment. And then you look at the women, and half of them receive the control, the other half receive the treatment. And then you compare the results afterwards, right? Who lost 50 pounds using the pill with the magic medicine in it, or the pill with the sugar in it that actually doesn't do anything to you, right? And so these are just different ways of organizing these types of studies. Now, it's important to understand who knows. And there's two terms that are included here. One's called the blind study, and the other one's called the double blind study. So in a blind study, the patient doesn't know whether they're getting the placebo or the treatment. Okay, they don't know. We don't tell them. We say, here's your pill, go lose 50 pounds. And then we know whether or not they're getting the real medication or the fake. Okay. And we keep track and watch the results. But there's a little bit of a problem in this, and it's subconscious. It's built into human psychology. If you are giving someone a medication and you know whether or not they're getting the real pill or the fake pill, you may have subconscious tells. Now a tell is familiar in like poker. You can tell if somebody's bluffing by a behavior, or a tell is when someone's lying. They can have tells like if you say one tell is like apparently if someone's lying, sometimes they'll touch their face or they'll look up and, did you go and put gas in the car? Yeah, I put gas in the car. Why? Is it on empty? Right. So there are different subconscious tells that people have. Again, one is touching the face. Sometimes when people are lying, their voice goes up an octave. They speak in a higher tone. Oh, yeah, I put gas in the car. Why are you looking at me like that? What'd I do? Right. And so it's best to double blind. Double blind means that the patient doesn't know what they're getting, and also the person administering the treatment doesn't know which is which. Now, make no mistake, somebody knows, right? Like there's somebody 3 layers back that is keeping track of who's getting what. But what this does is it prevents the person administering the treatment or the placebo from subconsciously giving away which treatment or placebo the patient is receiving. Because you don't want the patient to walk out of the exam room and say, yeah, I think I got the fake sugar pill. Well, what makes you think that? I don't know. I just got a funny feeling that, when the nurse gave me the medication, it wasn't the real stuff, right? That's your subconscious. You picked up on something. You felt like you were being like deceived for something. And so we want to prevent that. So double blind studies are the way to go. That is the star treatment right there. You want to make sure that if you're reading a review of an experiment, make sure that somewhere in there they say this is a double blind study. So the patient doesn't know and the person administering doesn't know what they're giving. Okay. If an experiment only has a blind study, maybe not so rigorous. You definitely want to do a double blind study. Okay. And then finally, the time over which an experiment takes place. So a cross-sectional study is just a single point in time. Here, fill out the survey. Thank you very much. We're done. Okay. A retrospective study is one that goes back and looks at historical records or information from the past. And so if you wanted to do a retrospective study on the population of a certain city, how did the city grow? You could go back and look at census records and measure, every 10 years, what the population of a city was. That would be retrospective. And then finally, and these are the most interesting, a prospective study or a longitudinal or cohort study is one that takes information from a single point in time and then tracks the participants usually throughout their lifetime, or sometimes a set number of years from childhood to adulthood, and then measures things. If you study psychology or sociology, they are filled with prospective studies or longitudinal studies. And one of the most interesting ones was you had a pair of students in kindergarten and you gave them marshmallows, right? And so you set one marshmallow in front of them and you tell the students, and again, these are kindergartners, so they're little tots, and you say, you can eat this marshmallow now, or I'm going to leave the room. And when I come back, I'll give you two marshmallows if you have not eaten your first marshmallow, right? And what this is measuring is delayed gratification. Can you resist the impulse of eating that marshmallow that's sitting right there in front of you? Can you hold out for more marshmallows at a later time? Okay. And so this first student can't wait. This first student eats that marshmallow. That is impulsive, right? They eat the marshmallow. The second student waits and the person leaves the room. They come back. That person gets a second marshmallow. Now they have two marshmallows and they enjoy eating two marshmallows, right? So you do this experiment early on with kindergartners, and then you follow these students throughout their middle school years, their high school years, their college years, their adult years, and you look to see if there's any patterns. And it turns out there is. The students that can delay their gratification, that can wait and hold off for the two marshmallows, tend to do better academically. They tend to have higher GPAs. They tend to work in jobs that have higher pay. They tend to get into relationships long term. They can delay gratification. They're not as impulsive. Where the first student here tends to be more impulsive, more quickly making decisions without really thinking things through. They tend to have a lower GPA. They tend to not progressive as far in academics, like they don't go on to college. Their relationships with other humans tend to be a little fragmented. And so this is a great example of a longitudinal study where you perform this seemingly innocent experiment early on, and then you kind of look and say, is that a sign of brain development? Like, is there a configuration in the brain that makes you impulsive? Are hormones releasing different types of things in your body that make you behave this way? It's all trying to unravel the human behavior system. So again, psychology, sociology has lots of longitudinal studies like this.